All right, I think we can now start. So again, welcome everyone. This is second live session of Learning Geology, Geoscience Field Experiences. Our speaker today is Dr. Christopher Spencer. This live session is presented by Learning Geology. Learning Geology is a community organization that aims to promote geoscience literacy worldwide. And we have been doing this from 2014 by producing a variety of content to promote geoscience education and also enhance geoscience literacy, not only among geoscientists, but also among non-geoscientists. For this project, which is Sustained Geoscience, we have been doing a series of live sessions. So we did a few days ago a live session with Dr. Wendy Bahan, which was Science of Earthquakes. So today is Geoscience Field Experiences, and in the coming days we will be doing a series of live sessions. So you're more than welcome to join. These are experts from these are renowned experts in their own fields, and we are so grateful to have them on board with us. You can register by visiting the link on the screen. A bit introduction by our speaker about our speaker today, which is Dr. Christopher Spencer. So Dr. Chris is a tectonics professor at Queen's University. And he is also an editor-in-chief of Traveling Geologist. Myself, I'm a co-founder of Learning Geology, and I'm a PhD student at University of Prince Edward Island in Canada. So in today's session, we will learn the importance of geoscience field experiences. We will learn that how Dr. Chris have been doing geoscience field trips and how these field experiences have enriched the experience of Dr. Chris as an earth scientist. And we will also talk about some of the challenges that we face in pursuing these experiences. So I'll hand over to Dr. Chris.
All right. Well, Kasim, thank you so much for that introduction. So I am going to share my screen and we'll get started. So as Kasim said, my name is Dr. Chris Spencer. I am a tectonics professor at Queen's University, and I'm really excited to join you today. Also, as Kasim said, that I am the founder and editor-in-chief of Traveling Geologist. And so it's a science outreach organization that I started as a PhD student and have been running for now almost 15 years. So I guess I'm sure that most of you here are geologists. You kind of know what's going on here, but we have to start out with an obligatory "what is geology" slide. So geo is the Latin root for the word earth, and then logi is the Latin root for study. So geology is literally the study of the earth. Now, generally, we think of the study of the earth as being what's happening beneath our feet. Where we study the crust, we study the mantle, and we study the core and the interactions between these different spheres, these different geospheres on the earth. But it's important to remember that geology is much more than just the study of rocks and the rocks beneath our feet, but rather geology is the study of the earth as a system. And so we have a photograph here. This is from Western Australia near Broome, where you can see a beautiful meandering river pouring out into the Indian Ocean and showing very nicely the interaction between what's going on in the ocean and the atmosphere with what's going on in the geosphere. So then what is a geologist? Well, this is a screenshot of Brad Pitt playing a geologist in the movie Ocean's 13, which is now very, very old and now dating me tremendously. So to spot a geologist, you only need to look for someone who is only includes people in photos for scale and has many more photographs of his or her rock hammer and lens cap than they do of their family and friends. A geologist is someone who who will willingly cross an 8-lane interstate highway on foot to determine if the outcrops are the same on both sides of the road. A geologist is someone who can pronounce the word molybdenite correctly on the first try, someone who has hiked 6 miles to look at a broken fence that was offset by a recent earthquake, someone who says this will make a nice Christmas gift while out rock collecting, someone who looks at scenery and tells you how it formed, someone who gets really upset when a countertop is called granite but is actually a gneiss, and someone who has a holster for their rock hammer. And although I don't have as much hair as Brad Pitt, I definitely can say that each one of those attributes has described me at one point or another. So what does a geologist do? Well, for me, it all starts in the field. It starts with geological mapping and geological sampling. We collect rocks from the surface and from drill core, which those are our primary sources of data. And this often requires expeditions to remote places, which is the topic of my discussion today, and I'll talk a lot more about that. And we use this to evaluate the spatial relationships of rocks so that we can make geologic maps. And then we can use those geologic maps to evaluate resources, hazards, and implications for human activities. So I started my journey as a geologist in Utah, where I was born and raised. On my first day of kindergarten, my mother asked me what I wanted to be or what I wanted to be when I grew up, and I immediately told her I want to be a geologist. And so from my earliest days, I wanted to be a geologist, and I then attended Brigham Young University, where I got my bachelor's and master's degree. After that, I moved across the pond, where I got a PhD from the University of St. Andrews in 2014. And then I went to the British Geological Survey for a couple of years, where I was an isotope apprentice. That was actually my official job title. I was an isotope apprentice. And then after a couple of years working for the British Geological Survey, I moved to the other side of the planet once again, where I was a research fellow at Curtin University. And this is a photograph of me at the Jack Hills. Many of you will know the Jack Hills for being famous because of the Jack Hills contain the oldest minerals on the planet. The oldest pieces of the earth are found in the Jack Hills, and these zircon crystals from the Jack Hills go back to 4.4 billion years ago. And then in 2020, actually in January of 2020, right when the pandemic started, I then moved from Western Australia to Ontario, where I started a position as a professor at Queen's University. So I've traveled around the world for my education and for work, but more importantly and especially for this talk, are the places where I have been as a field geologist. And so I've done field research on 5 different continents spanning 33 countries. Ironically, I've never been to Central or South America. I've not been to Antarctica yet, but I'm really looking forward to exploring those areas. The rocks that I have looked at, or the rock samples that I have collected, span the entire geological timescale, going back from the Jack Hills that I was mentioning, which the oldest zircons sit down here at about 4.2 to 4.4 billion years ago. And then I've collected rocks that span then from 3.2 billion years old all the way through to the present. And my research as a tectonicist drives me to understand the formation and evolution of plate tectonics through geological time. And so in addition to looking at some of the oldest rocks on the planet in the Archean and the Hadean, I also have been looking at very, very young tectonic systems in Japan and New Zealand, and actually currently hold the world record for having done geochronology on the youngest exposed granite, which is about 600,000 years old. And so my travels as a geologist have allowed me to see lots of exciting rocks, not only all across the planet, but also going back through geological time. So as kind of a guide to help me through this discussion, Kasim gave me a few questions that I wanted to address. And so the first question is, why do geoscientists conduct fieldwork? Why is it important? And then how much fieldwork is important to my specific field? And then what are some memorable field experiences that I've had? What are some limitations and challenges in gaining fieldwork experience? And then lastly, any advice for people who want to get into geology or the geoscience field? So starting off, why do geoscientists conduct fieldwork? Well, as I mentioned, for me, it all comes back to the lab work. And so field work is exciting, and I really love being out in the field, but the whole purpose of going out in the field is to collect samples that I can bring back to the lab, and then we can analyze those samples for a variety of attributes. And so you can see here some samples that we collected. So these samples right here, samples that we collected from Iceland, very unusual rocks that we weren't expecting to find in Iceland. And then one of my students here next, this is Marina, and she is using a rock saw to cut up some of her rock samples that she collected from Eastern Ontario or Western Ontario. You can see a beautiful migmatite sample here that has been cut up. This one is from North China. From there, we often will crush the rocks. We'll break them up into a fine powder, and then we will separate the minerals. And so what I'm doing here is I've poured out the sample on a sheet of paper, and then I have a high-powered neodymium magnet that I am putting across the sample to pull off the magnetic minerals. And then in this case, it's specifically magnetite. After we remove magnetic minerals, here's another one of my students. This is Si Wong, who is now doing a PhD at the University of Victoria. And she is using heavy liquids like diodomethane or tetrabromoethane to separate heavy minerals from light minerals. So in particular, we use a chemical called diodomethane because some of the minerals like quartz and apatite and feldspar that have a lower density will actually float in this liquid because the liquid is so dense. But then heavier minerals, things like gold or barite or zircon, pyrite, will then sink to the bottom of this glassware, and then we can separate those minerals. And then we see here picking some of those heavy minerals under a microscope, and then once we've picked those minerals, we can take them to a mass spectrometer. And this is the Shrimp 2 that I used in Western Australia at Curtin University. Shrimp stands for Sensitive High Resolution Ion Microprobe. And so we can use this, effectively a very large magnet, to separate the different elements that are in the samples that we're wanting to analyze. We can measure the amount of, for example, uranium, and then we can measure the amount of lead. And because over time, uranium will decay into lead, we can then figure out how old the rocks are. And so this is the primary reason why I am drawn into the field. And so a lot of the research that I do, as I mentioned, is focused on geochronology. But another aspect to all of this is trying to use geochronology to evaluate or to create a temporal framework. And we can then use that temporal framework to evaluate geological processes, how fast they're occurring, how often they've been occurring through the geologic past, and if there have been any changes in those processes through geological time. I mentioned that I am quite interested in the evolution of plate tectonics. And it's often assumed that the geological processes that are happening today are the same as what has been happening throughout geological time. We often refer to this as uniformitarianism, and uniformitarianism was first really discussed by James Hutton, who discovered an angular unconformity, where we had rocks that were originally deposited flat, but had been deformed and were then found to be at a very steep angle. And then we had other flat lying rocks that were deposited on top of that. That led James Hutton to think that the time frame with which geological processes are proceeding is much longer than we had previously assumed. And so he said that the processes that are happening today are the same that had happened yesterday, and we see no reason to think that they would be changing into the future. And while the principles of uniformitarianism, I think, are very important, and I think they stand and hold true to today, it's important to remember that the Earth is an evolving system, that in the interior of the Earth, we have radioactive elements that are constantly putting out heat, and that heat is then heating the core and the mantle, and that heat from the core and the mantle is then transmitted to the crust. And it's that heat from the interior of the Earth that acts as the primary engine for plate tectonics. And as the Earth continues to lose heat, there's less heat available. So over time, it is hypothesized that the Earth is cooling. Now, it's cooling relatively slowly because the Earth is very large and has lots of radioactive elements in its interior. But as the Earth cools, the processes that are reliant on that heat to move forward also are changing. And so in particular, I went to a place in West Africa called Ghana. Ghana is a beautiful country in West Africa, and Ghana is significant for geology because it contains a number of rocks that are of a very specific age, about 2.3 to 2.1 billion years old. And so this is at the very beginning of the Proterozoic eon, right after the Archean eon. And I went here with one of my PhD students. Her name is Yana, and while we were in Ghana, we collected a bunch of samples. But also, I made a little video about my time in Ghana, and so I wanted to share that video with you. So with no further ado, I'll start this video. And Kasim, will you make sure that you can hear the audio coming out of my computer?
In the heart of West Africa, Ghana is a tremendously beautiful country with incredible oxygenation. And so by doing so, we'll be able to tie a link between changes in the atmosphere to changes in the sediments to then even changes in the granites that are forming deep in the crust. Lucky for us, there were many quarries with fresh outcrop and eager folks to show us the way. The granites we were looking for also happened to be very useful for aggregate and gravel, and the quarry owners were very happy to let us take a sample. Aside from the spectacular rocks, we enjoyed a variety of natural wonders. Ghana will always have a special place in my heart. Undoubtedly, we will be back again to continue our geologic exploration.
All right, so that was some of the work that we've been doing in Ghana. So I made that video back in 2019, and so a lot has happened since then. Not including the pandemic, but in terms of the science, some of the things that Jana and I have learned is that indeed the composition of those granites record the oxygenation of the atmosphere. And this is really fascinating because it provides a pretty clear indication that the different spheres of the Earth, the atmosphere, the biosphere, the geosphere, these are all interconnected. And we can evaluate how these spheres have changed through time if only we can evaluate and constrain the interactions between things like the biosphere and the atmosphere, and then the atmosphere and the geosphere. And so there's a lot of really exciting research that has come out of our field trips to West Africa in particular, and I think that it's really important to highlight that traveling to places that have spectacular people, amazing geology, and really, really lovely food is exciting. But the primary reason why we travel to these field sites is so that we can address geological problems. So I'm going to share one more story about the Himalayas. So this is a photograph from a place called the Dalai-Ganga in Uttarakhand in India, northern India. And I've spent a lot of time in this part of India. During my master's degree, I moved here and I lived in the high Himalaya in a town called Badrinath for about 6 months. And I spent my time meeting with the locals, hiking through the mountains and collecting samples associated with my master's degree. And that was back in, I guess it was 2009. And then fast forward now 10 years, in 2019, I went back to northern India, this time with a PhD student named Charlie, who you'll see in a moment. And we returned to the Himalaya to address and answer some of the questions that were left unanswered from my master's degree. And so the other thing that's really exciting about being a field geologist is the locations that we visit usually don't change very much from year to year. Thankfully, geological processes usually occur on timescales that are very, very long. So when I went to the Himalayas in 2009, even though I spent many months in this area, I knew that I was not going to be able to address all of the questions that I had from the Himalaya. And so I was very thankful that I was able to then go back to the Himalaya in 2019 with Charlie, and I will now share another little video about our time in the Himalaya.
Flying into New Delhi is a magical experience, in particular because most flights come in along the Indo-Gangetic Plain and parallel to the Himalaya, with the Ganges in the foreground and the towering Himalaya in the background. Upon arrival, I met up with Charlie and we set off. This was Charlie's first time to India. Here we are in New Delhi in a tuk-tuk, heading to the hostel, and then we'll take the train to Dehradun tomorrow. On the train. Here it is. From New Delhi, we headed north towards the frontal thrust of the Himalaya, where sediments from the Himalaya, called the Shwaliks, are thrust on top of themselves as the entire mountain range moves to the south. Crossing the main frontal thrust, we entered the Dune Valley. Driving through the Dune Valley is absolutely spectacular because on one side, we've got the main frontal thrust, which is the very frontal part of the Himalayan orogenic system. And then on the other side, to the north of the Dune Valley, is the main boundary thrust. And this is where the rocks of the lesser Himalayan sequence are thrust up on top of this synorogenic basin and overrides the orogenic sediments. As we pass from the Shwaliks and the Dune Valley into the Lesser Himalaya, the topography dramatically changes from rolling hills to some proper mountains. We're now up here in the Lesser Himalayan sequence, which is part of the Indian passive margin that had formed going back even as old as 1.8 billion years ago. And all of this sedimentary material was then scraped off when India collided with Asia in the past 50 million years or so. And you can see down below me, this is the Ganges River. And this river represents the lifeblood of not only the communities that are living here in the Himalayas, but the communities throughout northern India. After driving all day, we started gaining elevation quickly as evening fell and the temperature began to drop. We're here at a place called Helong, and this place represents the boundary between the lesser Himalayan sequence and the greater Himalayan sequence. So right up this river valley here is the main central thrust zone. So this is the boundary between the unmetamorphosed sedimentary rocks and the high-grade metamorphic rocks of the greater Himalayan sequence. We stayed the night in the town of Geoscience, where we stocked up with supplies and headed off early the next morning. It is within the greater Himalayan sequence when you really start to get a feel for the scale of these mountains. The elevation gain was immense. We gained nearly 1,500 meters elevation in less than 2 hours driving. But being so close to the Chinese border and given the delicate political situation of the region, it was no surprise to see the Indian military along the road. I'm here in a place called Badranath, which is a sacred site for the Hindu people that is right on the China-India border. And we've come to Badranath specifically to understand the melting process that occurs in the high Himalaya. And we're here not only to understand the timing of the melting process, but also the chemical partitioning that occurs as melt is extracted from the host rock, and then it pools in melt bodies, starting out as small dikes and then coalescing into much larger granite plutons that are found up at the near the top of the peaks. After a quick visit to the Badranath temple, we began the trek into the mountains. Climbing another 500 meters in elevation, we arrived at base camp at 3,500 meters. All right, base camp number 1. Nice job, buddy. With the help of the amazing cooking of our friend Aditya, we were sure to have the energy we needed for the hard days of fieldwork that followed. Cold outside, but the view is too good to close the tent doors and check out the other side. Yeah. From base camp, we hiked up to about 4,000 meters here, and it never ceases to surprise me how much of a difference 2,000 meters elevation makes on how tired I get. But what is spectacular, as you can see behind me on this cliff face, some of the most spectacular granite dikes and migmatites that I've ever seen. And we're collecting some really good samples, but the best samples always seem to be just that much out of reach. But we'll do the best that we can. Well, it's started snowing. We're at 4,500 meters, and I guess that's not to be unexpected, given it's mid-October in the Himalayas, but all's well. After completing a successful sampling excursion and topping out at nearly 5,000 meters elevation, we began the long trip back to Delhi. But no trip would be complete without first bathing in the Ganges. Our trip could not have been possible without our friends at the Wadia Institute of Himalayan Geology. Immense thanks goes to Himanshu, Aditya, and Shashi for making our trip a great success. And thanks to Charlie for working hard and being a great sport.
All right. So, yeah, going to the Himalayas was pretty spectacular, and it's exciting because not only is the Himalaya home to amazing people and really spectacular geology, but the Himalaya plays a special role in our understanding of plate tectonics. And when you think about a mid-ocean ridge, you will probably think about Iceland, or when you think about a subduction zone, you might think about New Zealand or Mount St. Helens in Western North America. But when you think of a continental collision, invariably everyone will think about the Himalaya. And so those are two of the more memorable field experiences that I've had. I've made a few other little short videos that if you'd like to learn more about some of the experiences that I've had, you're welcome to go and watch those on the YouTube channel at Traveling Geologist. Yeah, lots of exciting things that have happened and lots of exciting things yet to come. So I guess then the next thing to discuss are what are some of the limitations and challenges in gaining fieldwork experience. And although I'm not yet 40, a lot has changed since I started in university about 20 years ago. And when I started university, it was very normal for universities to have nearly 2 months of field experiences for people's undergraduate. And then it was very unusual for a graduate project not to involve several weeks of field work. And more today, very unfortunately, a lot of universities are cutting their field programs or trimming them significantly. And I think that it's a very difficult situation because I strongly believe that the best geologists are those that have seen the most rocks. And those that are able to see the rocks really come to understand and appreciate the variability and the different processes that shape Earth's geology. But I also recognize that there are a lot of challenges when it comes to cost. Fieldwork is not cheap. It can be very expensive, and in many situations, doing international field travel is simply not possible for university students. And in addition to that, we also have to grapple with issues of accessibility, because not everybody is able to climb high in the Himalayas or even just to walk along a mountain trail. And so I think that some of those challenges we're still trying to come to grips with. We're trying to make geology more accessible, and trying to provide those opportunities to everyone who wants them. And I think then some things that we can do as a community to help understand and help understand the importance of fieldwork, but also help facilitate others to participate in fieldwork is looking for ways to help fund field excursions, but also to help build virtual field trips for those who are unable to come on the field experiences. It's a continual challenge, and I don't think that these are easy questions to answer, but I think what is very, very clear to me and very important is that those field experiences is very important to the training of our geologists, whether it's field experiences in your local area or whether it's field experiences further abroad. I think that the more that we can engage in fieldwork and that we can integrate fieldwork into our undergraduate education, the better our geologists will be for it. And then the last is advice for people who want to get into geology, into the geoscience field. I think that things have changed pretty dramatically since I was a student. The way that we teach has changed, especially after the pandemic. There's a lot of courses that are now going directly online, and field trips and field international travel is, although it is now possible, now that the pandemic has kind of waned, it is still quite challenging and can be very, very difficult for people. But I think that the key thing is to recognize the importance of field geology and the opportunities that field trips can provide our geologists in training, and then look for opportunities to get scholarships and to find those funding opportunities to facilitate the field work that you would like to do. I don't want to go on for much longer, but I'm going to skip ahead a little bit to talk about some of the things that I've been doing with Traveling Geologist. And so Traveling Geologist, as I mentioned, has been running for about 15 years now. And one of the things that we have recently started was hosting scholarships for students who have a financial need in order to go and perform their research or to attend a field course. And we've been able to fund these scholarships through generous donations, but also through merchandise that we sell on the Traveling Geologist store. So we sell everything from kind of silly t-shirts and field gear to things like hand lenses and rock hammers and compasses. And all of the proceeds that we get from the selling of that merchandise goes directly to funding these scholarships. So last year we had 2 scholarships that were given out to Ruth and Bruna. Both of them are PhD students. Ruth is from the Philippines, but doing a PhD in Germany. Bruna is from Brazil, but doing a PhD in Canada. And Ruth went back to the Philippines to do her fieldwork, and Bruna went to Hawaii to do her fieldwork. This year, we were fortunate enough to also be able to provide 2 scholarships to 2 more students. And Karen Pham is a PhD student from Penn State University. She's going to be doing her fieldwork in Madagascar. And then Ella Davis is also a graduate student from the US, from Virginia Tech, and she is going to be doing her fieldwork in northern Scotland. And so the opportunity to get scholarships is out there. There's not always enough money to provide everybody that needs a scholarship with a scholarship, but we're doing our best to help provide a little bit of funding to help make field experiences for our students possible, and to really highlight the importance of field geology in everything that we do. And so with that, I'll stop my presentation here, and I'm happy to take some questions and to discuss anything more that you'd be interested in for me to discuss. So yeah, thanks everyone.
Thank you, Chris, for the amazing presentation. So everyone, this is the time for Q&A session. So if you have any questions for Dr. Chris, please, you can ask now in the comments.
I see from people in the comments that we've got people from Ghana. I see Michael at Design, and others from Scotland. Paul, hi, from Scotland. Yeah, and Stephen from Senegal. It's great to see all of you here. Any questions? Well, then maybe while some of you are thinking about some questions, I'll share a couple of other things that I was thinking about with regards to science outreach and kind of how we can be engaged in science outreach. And so I made this little chart to evaluate the impact of our outreach activities, and then compare that with the outreach, with the number of people who are involved in that. So again, on the y-axis, we have the number of people who are exposed to the results of scientific research. And on the x-axis, we have the number of professional scientists that are involved in sharing the results of their research. And so on one end of the spectrum, we have institutional efforts, things like specific research programs. So like my website for my specific research program, for university open days or summer schools. Unfortunately, there's not a large number of professional scientists that are engaged in those institutional efforts. Oftentimes, they're run by a single person or maybe 2 or 3 professors at a university, and therefore they don't reach a large number of people. Working our way up to increasing the impact, we have things like the AGU blogs, the GSA blogs, and then we have Twitter and Instagram accounts that have garnered tens of thousands to even hundreds of thousands of followers. And it's these kind of social media and blogging efforts that really reach a large number of people, but even still, we have a relatively small number of professional scientists involved. And then the next step is going in the other direction, where we have international conferences, things like the European Geophysical Union, which is actually happening now in Vienna, Austria. We have the American Geophysical Union meeting, the Geological Society of America, or the Geological Association of Canada. These large international conferences have lots and lots of scientists that are engaged in communicating their science. But unfortunately, they don't reach a lot of people aside from those people who are attending the conferences. And then we can go on the complete opposite end with things like popular media. So we have Mythbusters or Planet Earth. We have really popular YouTube channels like Veritasium and SciShow, where they have the largest impact, where they expose the scientific results to a very, very large group of people. But unfortunately, again, there's not a lot of professional scientists involved. And you can probably count on one hand the number of professional scientists that are involved with these specific popular media endeavors. And so the question is, how can we get something out here in this part of the diagram where you are reaching a large number of people, and you are then engaging with a large number of professional scientists? And so this was the reason why I created Traveling Geologist. And so the hope was that we would be able to have a broad impact. We'd be able to reach a large number of people, but we would also be able to engage a large number of professional scientists. And so Traveling Geologist, I'll skip through this a little bit. So far, we have had over 300 articles that have been written on travelinggeologist.com from 80 different institutions and universities. The authors are from almost 20 different countries. The webpage has received hundreds of thousands of unique visits from unique IPs, with over 2 million page views now. Over 50% of the contributors are students. We have a very nicely balanced male to female ratio between our contributors. And most of the people that are reading Traveling Geologist are university students and high school students, and that has now shown us that it is a useful way for us to engage with a large number of people, but also provide an opportunity for lots of scientists to be involved in some of these outreach opportunities. And I know that Learning Geology is doing very similar things. And so it's really exciting to see how some of these integrated social media platforms are able to engage not only with high impact science outreach, but also are able to reach out to a large number of professional scientists and engage the general public with a large number of professional scientists. And so I'm hoping that the science outreach, that things like Learning Geology and Traveling Geologists can continue, and that through our science outreach efforts, we'll be able to reach a large body of people, but also engage with a large amount of scientists and sharing the results of their work. So I guess with that, I don't think we've received any questions. So Kasim, is there anything else you'd like me to talk about?
Thank you so much, Chris, for the wonderful presentation. I think you have covered almost everything, and also thank you so much for that bonus presentation about the outreach. And that plot has been so amazing to see that that traveling geologist, and we need to do something that has more impact, and also outreach as well, so that every scientist with their unique expertise, they are involved as well. Thank you again, and thank you everyone for joining us today. So we have one question. It's from Mohammed. It's for, what is your advice to geology PhD students?
Well, Mohammed, that's a very broad question, and I think advice in general. I think remember that it's going to be hard. That part of the purpose of a PhD is to really challenge you and to provide an opportunity for you to break down some of the personal barriers that could be holding you back. And so it's difficult. There's no doubt about it. But stick with it, even when it gets hard. Stick with it and push through some of those challenges. But don't push through those challenges alone. I think maybe the best advice that I can give to any graduate student is to seek a community that you can work with, whether it's in your own university, whether it's online or wherever it is. Really seek for an opportunity to engage with others who are doing graduate research or similar research to your own. And I think by establishing that community, it really does provide an opportunity to overcome those challenges together and to learn to empathize with some of the difficulties that all graduate students face. And so I think the biggest advice is be perseverant and find a community to help you through challenging times.
Thank you, Chris. And it was great to see again your field documentaries. I have almost watched all of the videos that you have on your YouTube channel of Traveling Geologist. So do you have any plans to make another documentary?
Yes, I mean the past few years has been difficult with field travel, but we do have some plans in the works to do some more field work. And I'm hoping to go back to West Africa. Hopefully this time we'll be able to go to Côte d'Ivoire and to Burkina Faso. And so definitely there will be more opportunities to make some documentaries and to involve some students in some interesting research.
That sounds amazing. Looking forward to it.
All right. Well, then I think with that, I'll probably sign off. Thank you everyone for attending. Please, if you've got any questions about some of the things that I've discussed in this presentation or just general questions, I'm happy to engage. Feel free to send me, either you can send me a message on Instagram or on Facebook, or you can just send me an email. And so it's pretty simple to find me online. Just Google Chris Spencer Geology, and you'll see some of my contact information on the Queen's website. And yeah, I'm happy to discuss things that anyone would like to discuss. In fact, I will even put my email address in the chat. I wish everyone a good luck in their geologic endeavors, and look forward to seeing you all in the next Learning Geology live session. So thank you, Kasim. And
thank you, everyone. Have a great rest of your day. Thank you.